The next conic section we want to look at is the parabola. And the parabola might be the one that we've been most used to and accustomed to because a lot of our work after we did linear equations has been with quadratics or shapes that have parabolas. As we look at these conic sections, we're going to start with the standard form of the parabola, which is different than what we're used to right now, which is y squared equals 4px or x squared equals 4py, depending on which direction the bowl is facing. In this one right here, the axis of symmetry is the x-axis. Y squared equals 4p. P represents the point of the focus, the distance from the vertice to the focus. And this line that we have over here opposite that is called the directrix. Now what that means is that while we have a parabola, any point on a parabola that you can come up with is equal distance from some other arbitrary line, or not from arbitrary line, but from other line that we have out there. So these distances are the same. The distance from here to there is the same. So every point that's midway between directrix and the focus represents all the dots that connect the line or connect the parabola and make one smooth curve. We can also have parabolas that hold water, which means that it has an axis of symmetry on the y-axis. Its directrix is the line y equals negative b. And again, we have a vertex and a focus as well. So those are some of the characteristics of a parabola that we want to start with as we start to build our way through of what we can do with parabolas. So the example that we're going to look at first, we have a parabola y equals 12x. Excuse me, y equals 12x. Y squared equals 12x. I think that's what I kept meaning to say. So let's go ahead and try and graph that. What we know then is that we have y squared equals a 4p times an x. If that's the case, then the 12 equals 4p, and then p equals 3. Now we have some information here that will allow us to start to draw our graph. We know the graph will push out to the right. It goes through the origin. We have its focus at the point 3 and 0. Let's draw some tick marks. So our focus point is at the point P and 0, which is 3 and 0. Our directrix then is x minus p, or at the line x equals minus p, which is a negative 3. And then if we want to, we can look at a couple of points on here too, just to have I know that this point right above it up at 6, that point's on the line because it's 6 units away from the focus, and that point is 6 units away from the directrix, which by definition is a parabola. And now we're able to graph that parabola where we're able to graph the directrix and its focus, and then every point along this way is the same distance to the focus as it is to the directrix. X squared equals negative 8y. Let's find out what we can in order to start to graph that, because I want to figure out where its focus is at, and also to where its directrix at as I graph it. We know that it follows the bowl that holds water or drops water. So it's an x squared equals 4py. So 4p equals negative 8. P equals negative 2. So let's go ahead and start to sketch out our axes. That's probably a bigger tick mark than I needed. We know that we have a focus at negative 2. My directrix then is at the line y equals negative b, so that'd be a line y equals 2. So I have a directrix right there. And then I could look at some other points that I know that will be on the line for sure. I know this point over here, over 2 units. Well, let's see where those points are at. That's 4 away, up 4. Let's put one more tick mark on there. I know that point's on the graph, and that point's on the graph because it's 4 units away from the focus, and it's 4 units away from the directrix. Likewise, this one's 4 units away. 4 units away, definition of a parabola. Parabola goes to the origin on this one. And there you have it. We're able to graph that one. Now, one other note here that you will find interesting, especially if I have my graph to the right scale. So let's go ahead and find a color that we haven't played with yet. There's a term called the latus rectum. Don't worry to make it up, Latin term. You're not going to need it until Jeopardy. But what that represents, if you see it, is this line that if I took the line from the focus and extended it out horizontal or parallel to the x-axis in this case, and where it intersects the graph at, that segment right there is called the latus rectum. And basically it says is that the distance between the vertices and the focus, in this case, is 2. The distance from the focus to the point straight across would be twice that. So that was a distance of 2. That would be a distance of 4. That would be a distance of 4 as well. And so that's what we call the latus rectum. So we have directrix, latus rectum, parabola. Lots of crazy things happening everywhere.